I want to quickly have this session here, just so you can benefit everyone watching. And particularly, this session is a recorded class for the student of further mathematics. Yeah, the class can also benefit those who are preparing for UTME mathematics, precisely because one of the topics that would also be tested is permutation and combination. So for this session, I'll see how we can make it short so that it can be a very short class that would have all that you need to understand the concept of permutation and combination. So when we say permutation, so now this concept is basically about arrangement. In the two concepts, what we're trying to do is to arrange. Do you understand that now? So this is what we're doing. We're arranging items. So there are different things we can arrange. We can arrange numbers, we can arrange letters, we can arrange items. Do you understand that now? So arrangement is basically what we're trying to do here. So sometimes, yeah, they'll say counting, but I prefer to use arrangements. Do you get? Now, in permutation, the arrangement is in such a way that the order of arrangement is important. The order is important, is relevant in permutation. So if you're arranging in such a way that the order is important, then that's permutation. But if the arrangement is in such a way that the order of arrangement is not important, is not relevant, then that's when you have combination. So that's the difference between permutation and combination, basically. So I'll give a very good example. Let's say the word cat, the letters in the word cat. If they ask us in how many ways can this letter be arranged, right? So it is either we have this cat or we have CTA. We can have ACT or we have ATC. We can have TCA or we have TSA. So these are all the possible arrangements. So you can see that this can be arranged in 6 ways. So the letters of the word cat can be arranged in 6 ways. Let me take 2 letters, or let's say so. In how many ways can the letters of the word so be arranged? Is that you have SO or OS? So this is 2 ways. Do you understand that now? So this is 3 ways. So this, what we just did here, and here, we have permutated. We have arranged the letters of the word cat. So what is not always going to be, it's not always going to be easy for us to list out all the items. Imagine they ask you to arrange the letters of the word Bologna. Okay, I'll be Manchester City. So you see that the word is a very long one. So for you to say you want to start listing out, it's going to take a toll on you. So for that reason, we have the idea of permutation comes to play. Okay, but before I go into permutation deeply, another concept that you need to understand is the concept of factorial. The concept of factorial. The symbol of factorial is this symbol, this exclamation symbol. Do you get? The factorial of a number is the multiplication of all the first natural numbers until that number. The multiplication of first natural number until that number. So it means if I'm looking for the factorial of 4, if I'm looking for 4 factorial now, I'm going to multiply all the natural numbers until 4. And that's 4 times 3 times 2 times 1. So that's 1, 2, 3, and 4. So you multiply all the natural until that number. So it means you're looking for 3 factorial now. 3 factorials will be 3 times 2 times 1. Do you understand? So it means if I'm looking for 2 factorial, it's just going to be what? 2 times 1. That is multiplication of natural numbers until that number. So by that now, it means if you are asked to look for 5 factorial, if you are looking for 5 factorial, what do you think that would be? That would be 5 times 4 times 3 times 2 times 1. So what do you observe? You start from that number, you reduce, you keep reducing until you get to 1. I hope that's clear. But there's something here that I also want you to observe. You see this 4 times 3 times 2 times 1. You will agree with me that it is the same thing as 4 factorial. This 4 times 3 times 2 times 1. So it means I can rewrite 5 factorial as 5 multiplied by 4 factorial. I hope that's clear. That's if I need it. Or it can also be 5 times 4 times 3 factorial. Does that make sense? So this is what factorial is all about. So it means if I'm looking for n factorial now, n factorial is going to be n times, you reduce it by 1, that's n minus 1. You reduce this by 1 as well, n minus 2, until you get to 3, 2, and 1. 3, 2, and 1. So this is what you have for n factorial. Again, this can also be rewritten as, because I know that what I have here, from here to here like this, from here down to 1, from here down to 1, right, is actually n minus 1 factorial, if you agree. when you take n out, so n minus 1 times n minus 2 until you get to 1 is the same thing as n minus 1 factorial. Do you get? So I can write n as n times n minus 1 factorial. So you need to understand this as well. So, and it is from this that we now realize that if n is 1, if n equals to 1, it means 1 factorial will be equal to 1 multiplied by 1 minus 1 factorial. So that's, of course, 1 factorial is 1. Do you get? 1 times 1 minus 1 is 0, so this is 0 factorial. So 0 factorial is 1. So this is another thing we need to note. That's 0 factorial is equals to 1. Do you understand that now? Now, sometimes question can come on factorial itself. I ask you a question on, they want to test your understanding on factorial. Do you get? So I'll give you maybe 1 or 2 examples here and there and see how that works. So let's say, for example, let's say we want to evaluate or simplify or whatever 8 factorial divided by 4 factorial. Now, so someone can say 4 year 1, 4 year 2, and that will be wrong. Okay, and factorial cancel factorial. No, it's not done that way. So you want to solve this 8 factorial divided by 4 factorial. So all you just have to do, you know that 8 factorial, you have to list it until you get to 1, right? You have to list 8 times, 7 times, 6 times, 5 times, like that. But because I know that what I have at the denominator, this 4 factorial, I can get it along the line. This 8 now, this is 8 times 7 times 6, right? Times 5 times 4 factorial. I will stop at 4 factorial because at the denominator, I have 4 factorial. So I don't need to write 4 times 3 times 2 times 1 because I'm still going to, eventually, it's still going to cancel out. So there's no point writing it. Do you get now? There's no point writing it since I'm still going to like cancel it eventually. How that's clear now? With the look of things, you can see that this 4 factorial will cancel 4 factorial. This guy will cancel this guy. And then our final answer will be 8 times or 56 times 30. Do you get now? Which is 1,680. So this solution is 1,680. Is it clear now? So that's a basic example. You can have different examples. But now the reason why it's very easy for us to cancel is because there is no other thing other than those 2 numbers. But assuming what you have is an addition or subtraction at the numerator and you have only a single value at the denominator, in that case, you will need to actually evaluate like properly. So you can't cancel in that case. Do you get what I'm saying? Like, let's say, for example, you want to evaluate 7 factorial minus 5 factorial divided by 3 factorial. So there are 2 ways you can do this. The first way is to like factorize, something out. Do you get the gist? And in my opinion, what you can factorize here easily is 3 factorial because of that denominator. Do you get? So it means what I'm saying is that, okay, that numerator where I have 7 factorial, I can have 7 times 6, right? Times 5 times 4, then times 3 factorial, minus 5 times 4 times 3 factorial, all divided by 3 factorial. Do you get now? So I can see that 3 factorial is common to them. So this 3 factorial cancel this one and this one. That's when you factorize out. Do you understand? Is to cancel these 2. So you now be left with 42 times 20, and then you now have minus 20. So this is 840 minus 20, which is going to give you 820. Okay, so what I did here was to factorize. So it's like saying 3 factorial is common, bring it out. You'll be left with 7 times 6 times 5 times 4. 3 factorial is there, bring it out, 5 times 4. And that 5 times 4 is 20. This guy here is 840. This one would have gone. So you have 820 at the end of the day. So it can be as simple as this. And it can be as a bit tricky as, let's say, example 3. Let's say you are asked to, simplify. Let's say we're asked to simplify n plus 1 factorial divided by n minus 1 factorial. Yeah. So this is it. So the first question you ask yourself in this case is, between n plus 1 and n minus 1, which one is bigger? You would agree with me that it is n plus 1. Do you get? Because n minus 1 is showing reduction, n plus 1 is showing addition to n. So in that case, the one that is bigger can be reduced until it gets to n minus 1 factorial. So what do I mean? It means that I can rewrite n plus 1 factorial. I can rewrite it as n plus 1 multiplied by n minus 1, then factorial. Do you get? Remember that the rule of factorial is that you will keep multiplying until you get to your desired factorial, or you get to the end of the natural number or the beginning of natural number, which is 1. Do you understand? So that is it. It means our question now, which is n plus 1 factorial divided by n minus 1 factorial. We cannot factorial. Then divided by what's now? It's going to be all divided by n minus 1 factorial. So at this point, something can cancel out. N minus 1 factorial can cancel out. So the final answer will be n multiplied by n plus 1. How that makes sense? So you can simplify like this. And sometimes this same thing that you're given, you can say it's equal to 42. Find the value of n. This same question, you now say this guy here is equal to 42. So all you just have to do is your final answer will be equal to 42. And you find the value of n. In that case, what are the two numbers that when you multiply together? Two consecutive numbers that when you multiply together, you get 42. That's 7 and 6. You can solve it quadratically to get your answer. But I'm just trying to show you possibilities so that you don't always say, we're not taught this, so and they did not teach us this, and I've not seen this before. No, you have seen it before. You just need to use your head to know that okay, this is what the man is saying. Do you get that? So that is it. The next thing that we will now come back to our permutation. So let's come back to our permutation again, which is here. Okay, which is here. Now, to continue with permutation, I would like to give you a rule, a standing rule. Okay. And what are these rules? You will need the rule actually for your understanding. You are going to need the rule. This class will be in two ways. The first part is going to be like explanation, general explanation. The second part is solving past questions so that there can be perfect understanding of what we are doing here. On permutation, let me give you a rule. The first rule I like to give in a class like this is that the first rule says if an operation can be performed in P ways and another operation can be performed in Q ways, then both operations can be performed in P times Q ways. In P times Q ways. So this is the first rule. I like to give this in the class. That is, if you have like two operations that you're trying to perform together, and one of the operation can be done in certain number of ways, the other one can be done in certain number of ways, then both of them together can be done in like the multiplication of the number of ways each of them can be done. You will need this rule, and when we get to where we're going to apply it, I'll let you know. So now let's come back to permutation. You remember that I said in my class, usually I like to make students see the behind the scene. But I'm afraid because this is an exam class, this is more like a revision kind of class. So if I'm to dwell deep into that, don't worry. You can always reach out to me. Yes, you can enroll in our programs for you to like have a better insight. But we are doing this for the sake of your preparation for exam. So for that reason, I will try to skip it. So let me go to permutation of R items from N items. It means that out of, let's say, 3 items, we want to arrange 2, for example. Out of 5 items, we are interested in arranging 3 or 4 or 1 or 2. Do you get? So permutation of R from N. We usually write it as N permutation R. So if you are arranging R from N, that's N permutation R. And the formula is N factorial divided by N minus R factorial. Luckily for us, we have done factorial, so this will not be a new thing for us. In your exam, question can come directly and it can come in situational. Question can come directly and it can also come situational. I'm going to use a demo question because I don't have any access to any of your textbooks or something, but I can always give you a demo question that's anywhere you go, as long as you understand this explanation, there's no question they can give you, you'll definitely be able to solve them. So now, I said that when you are arranging R items from Ni, so the condition is that your R or your N must be greater than or equal to R. That's the condition. In the list of it, R and N will be equal, but N must not be less. No matter what, N must not be less. Do you understand what I'm saying now? So that is what it means. We're going to look at different instances. We're going to look at different examples and then. So the first example I'll give is a direct question, which is possible in your exam as well. You can give you direct questions on permutation. So how does it work? Now look at it. Example. So you can say you should evaluate 7 permutation 3. So if you want to solve this, of course, I don't expect this in theory. So 7 permutation 3 here is going to be 7 factorial. If you look at the formula, divided by 7 minus 3 factorial. I'm applying the formula directly. Do you get? And what's 7 factorial? So this is 7 factorial. You know 7 minus 3 is 4. So I'm going to reduce 7 until I reach 4. So that's 7 times 6 times 5 times 4 factorial divided by 7 minus 3 is 4 factorial. So that's 4 factorial. So of course, this 4 factorial will cancel out. And then you have 30 multiplied by 7, which is going to give you 10. So the final answer here is 210. You see, this is applying the formula directly. So sometimes permutation is about the kind of question you're going to see. They will just give you and you would apply it directly. Exactly now. And then we say sometimes it is possible for you to be given situational problems. Now, suppose they said in how many ways can, okay, I would like to type that out as example, whatever. I don't know the number of examples we have. Let's take this as another example. The question is in how many ways can situational, I call it situational, right? Because this one now is not giving you the question directly. It's giving you the question in such a way that you will be forced to use your head and use the formula now. So let's say we're asked in how many ways can three books be arranged in 5 compartments of a shelf. So this is situational, can you see? So we have 3 books. I want to arrange those 3 books in 5 compartments of a shelf. I hope you are following. In how many ways can 3 books be arranged in 5 compartments? So this is like out of 5. That means our n is 5 and our r is what? Is 3. Do you understand that now? So the number of ways is going to be 5 permutation 3. Do you get? So the number of ways is 5 permutation 3 equals 5 factorial over 5 minus 3 factorial. And this guy here is now going to be 5 factorial over 2 factorial. And what's 5 factorial? That's 5 times 4 times 3, right? Times 2 factorial divided by 2 factorial. So the 2 factorial can cancel out. And then our final answer is what? 60 ways. Alternatively, understand this approach is going to help you a lot. Alternatively, you have 3 books into 5 compartments, right? So I have this, I have this. These are the 3 books. I want to arrange them in 5. So the first book can occupy 5 different positions. These are the 3 books. So the first book can occupy 5 different positions. So that's 5 ways. That can be done in 5 ways. Do you understand what I'm saying? Like these are the 5 compartments now. These are the 5 compartments. So I have 1, 2, 3, 4, 5. So the first book can either be here or here or here or here or here. That's the first book. So once that one has been established, that one can be done in 5 ways. Let's say the first book is down here. This is where the first book is. The second book can occupy any of the other 4 positions. That's in 4 ways. That's 4 ways. And the third book, let's say the second book, we now place it here. Book B. Then the third book can occupy any of the remaining 3 positions. That's in 3 ways. Remember that I said if an operation can be performed in P ways and another one can be performed in Q ways, then both of them can perform in P times Q ways. So if there are more than 2 operations too, you just have to multiply the number of ways you have for each of them. So that's going to be 5 times 4 times 3. And this is going to give us 60 ways. I hope this is okay and understood. So that's another question. It's situational. Do you get it? So sometimes you see a situational problem like that. Or they ask you, in how many ways can the letter, that's example, let's say example 3. I don't know if this is example 3 anyway. Now the question is, in how many ways can the letters in the word Shade be arranged? Here, you want to arrange 5 letters from 5 letters. So you can do it in 2 ways again. Okay. The first way, solution now. The first way is to say that the number of letters you have is 5. And you're arranging the entire 5. So that's simply 5 permutation 5. This is the first approach. And 5 permutation 5 is going to be 5 factorial over 5 minus 5 factorial. 5 factorial is 120. If you don't know. 5 minus 5 is 0. 0 factorial is 1. So the final answer is 120 ways. Should you ever answer? Do you understand? So this is 120 ways. Now, our answer is 120. But you can also say that Shade, you have Shade. There are 5 letters here. That's the number of ways of arranging the letters of the word Shade. Do you understand that now? Letters of the word Shade, 5 factorial. And 5 factorial is simply 120. By the time you reduce it, that's 5 times 4 times 8 times 2 times 1. That's 120 ways. So going by the same way, if you want to arrange the letters of the word Wale, Wale is just going to be 4 factorial, and 4 factorial is 24. We also have Adio. Adio, that's also 4 factorial. Do you get now? But you have Son, S-O-N. This one is going to be 3 factorial. Do you get? So all these are also things you can also see in the exam. So after this, that's still on permutation. After this, then we can now go to permutation in a circular object. Permutation, cyclic permutation. Let's use that language. Cyclic permutation. Now for cyclic permutation, it means you are arranging in a circular manner. And when you arrange in a circular manner, what normally happens is that you are going to fix one item first. Do you understand that now? Fix one item, you fix it. That will now be your reference. Because it's a circle. A circle does not have a starting point and an end point. So but the moment you fix a one item, I mean, if you fix just one item, that one item you fix is going to be your starting point. It's going to be your reference point. So that can be done in one way. Then the remaining n-1 item can be done in n-1 factorial ways. So in total, if you're arranging in a circular manner, the number of ways of doing that is going to be 1 multiplied by n-1 factorial. The first one is the one you fix, which is a reference. The remaining one, and out of n, after you remove 1, the remaining ones is going to be n-1 factorial. So and that's what you have. I hope this is clear. Okay, so if you ask, okay, that's 8 people are having a round table meeting. How many ways can they sit in that round table? It's going to be 1 times 7 factorial. Do you get one? And so on like that. So yes, this one is possible for your level. There's also across a ring. So if it is a ring permutation for ring, because a ring can be twisted the other way around. So because ring can be twisted the other way around, so we have n-1 factorial, okay, divided by 2. This is the number of ways if it is across a ring. How this is final. So we also have this. Now, after this, we also have conditional permutation. Conditional permutation. Let me explain what conditional permutation is. Please, if there's anything you do not understand, feel free to drop it in the comment section. I'll find time to explain maybe in another video. You can reach out to us. The phone number will be in the description section. So reach out and we'll explain to you better. So we're talking about conditional permutation. Now, what do you mean by conditional permutation? Now, it's possible for you to want to arrange items such that you now have a condition attached to it. So when a condition is attached to your arrangement, you have what we call conditional permutation. When a condition is attached to your arrangement, is your arrangement, but there's now a condition that is attached to it. In that case, you have what we call conditional permutation. And that's what we want to look at now. Now, another rule. Another rule I want to give you is that the number of ways of arranging any item, is equals to the number of ways of arranging it, number of ways of arranging with restriction. This one is without restriction, Sha. You can call it without restriction. So let's call it without restriction. Don't mind the handwriting. I mean, I don't know what's wrong with my pen. So the number of ways of arranging without restriction is equal to the number of ways of arranging with restriction. with restriction plus the number of ways of arranging with reversed restriction. So that is it. This rule is going to save you a lot of stress. So let's say, for example, they ask you, in how many ways can 10 people sit? If two particular people must sit together. When you see if, that's a condition. If two particular people must sit together, must always sit together. In that case, there is a condition. And what's the condition? Two people must always sit together. Do you understand? That's a condition. So you now say that you will first find the number of ways of of arranging. The number of ways of arranging those 10 people will be 10 factorial. That's without restriction. But now there is restriction. It's no more going to be 10 factorial. So I'm going to show you real practical now. Let me show you real practical. Let's say they say we should arrange the letters of the word. We want to arrange Shegun. If E and U must always be together. Must always be together. Here we're trying to arrange Shegun. If E and U must always be together. So what do we do? So what we do is that solution. I'm just using this as a demo to explain what is going on here. So if E and U must always be, so E and U will be taken as one. Will be taken as one entity. Because they must always be together. Do you understand that? It means what you now have, the remaining letter, we have S, G, N, Abi, and then the E and U must always be together. So take it as one entity. So you always take it as one entity. So it's now looking like you have 4 items. 1, 2, 3, 4. And if you want to arrange 4 items, your answer will be 4 factorial, Abi, 4 factorial. But you will not stop there because you now multiply by E and U within themselves. They can be arranged in 2 factorial. In 2 factorial ways. E and U can be arranged. It's either it is EU or UE. Do you understand? It's either you have EU or UE. So normal, you will take it as though you have 4 items. And those 4 items are SGN and the one entity. Although there are 2 letters above, it is just one entity. Because they must always be together. If you don't take them as one entity, there is high possibility that they will scatter. E can go its separate way. U will also go its own separate way. But when you take them as one entity, they will always be together this way. So here now, it's now looking like we have 4 items. And 4 items can be arranged in 4 factorial ways. But the E and U can also be arranged in 2 factorial ways. Remember the rule I gave you. If an operation can be performed in P ways, another one can be performed in Q ways, then both can be performed in P times Q ways. So that's what is going on here. That's why we multiplied. Is it clear now? Please, there is anything that is not clear, ask it in the comments section. We'll take time to attend to it. Is that clear now? And we know that 4 factorial is 24 and 2 factorial is 2. So the final answer is 48 ways. So this is a conditional permutation. Do you get? Now, if you now say that this is if the 2 U must always be together. Now, secondly, now this same question: if the E and U must always be apart, must always be apart. Now, what you can easily get from the question is if they are always together. You can't easily get if they are always apart. So what do you now do? You now go back to the formula I gave you. What was the formula? The number of ways of arranging without restriction. So we know that without restriction, number of ways of arranging Shegun now without restriction. What will it be? It's going to be without restriction. It's going to be Shegun has 5 letters. So it's going to be 5 factorial ways. And 5 factorial is 120. Do you understand? Again, go back to the question. Now, I know 2 things. You know, this question says, if E and U must always be apart. If E and U are, and we have already gotten where E and U are always together. So the number of ways of arranging Shegun is going to be equal to the number of ways of arranging it if E and U must always be together, plus the number of ways of arranging it if E and U must always be apart. Together is this with restriction. Apart if with reverse restriction. If they are not together, it means they are apart. If they are not together, it means they are apart. And that is what is going on here. Permutation is a very tricky subject. It gets scattered even in the hands of a lot of teachers. During explanation to students, during, and you're lucky if you're watching this video, you're lucky because this video will give you a deep understanding of what really goes on So you need to understand. And textbooks do not help because most of those textbooks they don't really explain as much as you need to understand. But I hope this is providing a very good foundation to your understanding. So now the number of ways without restriction of arranging schedule is 120. So it means that number of ways that we are now looking for now, number of ways of if E and U, if E and U are apart, is now going to be 120 minus 48. Where is this 120 coming from? It's coming from the number of ways of arranging without restriction. The 48 is coming from the number of ways of arranging when they are always together. And we said when they are, look at it again. Number of ways of arranging without restriction is equal to number of, so in this question, number of ways of arranging schedule is equal to number of ways of arranging schedule if the E and U are always together plus number of ways of arranging schedule if the E and U are always apart. Now, without restriction, we got 120. When they're always together, we got 48. It means if you want to get this, you just subtract 48 from 120 and you get your answer. I hope that's clear. I don't know if this make a lot of sense to you, Sha, because a lot of students, when it gets to this stage, they seem not to understand. So I was asking what's 120 minus 48? Oh, that's 72. So that's the answer. So I've just applied this rule here now. So you can go to your textbook, come up with questions. We'll also find time to attend to it. Do you understand that now? But don't forget to follow and share this with your friends. Those of them that are praying for GCE, WAEC, NECO, and stuff. They'll need this understanding. So share with them. Don't forget to subscribe. Don't forget to subscribe. Don't forget to subscribe. Don't leave except that you subscribe and like and share this, and then join our program as well. It's very, very important. Here, what we're trying to do is to make sure that you have a very solid understanding of what we are doing. So that is it. And if you have personal issue, you can reach out to that number and book a call with us, whether with us or your parents. Tell your parents you can call us anytime. We are here to help you excel in your academics, not just in maths, in all of that, across all your subjects. So that is conditional permutation. That's how it works. And this is all that you need to understand. And lastly, that I would like to teach you under permutation is permutation when the objects are not what? When the objects are not distinct. So let's call it permutation of indistinguishable objects. Of indistinguishable objects. Are we together now? Good. Now, I said permutation of indistinguishable objects. So that is, if you want to, let's say we have n objects such that P1 are of the same kind, P1 of it are of the same kind, P2 are also of the same kind, and let's say PK, it continues like that, and let's say PK are of another kind. So let me use it one after that. Let's say P1 are of the first kind. Let's say first kind. Are of the same first kind. Are of the same first kind. P2 are of the same second kind. Second kind. PK are of the same kth kind. Okay. So in that case, if you want to arrange the n items, the number of arrangements in that case is now going to be n factorial, which is the normal way, but divided by the one that has the first kind, which is P1. So that will be P1 factorial times P2 factorial, and it will go on and on until that PK factorial. Let me explain what's going on here. It looks abstract, but I will explain what it is. Are you there now? So what you have is that we are trying to permutate n objects, of which P1 are of the same, like they are the same kind. P2, they are also of the same kind. PK are the another kind. So all those ones that are like of the same kind, within themselves, they can be arranged in each factorial, like P1 factorial, P2 factorial, and all that. So you are going to be divided by the multiplication of each a factorial of those ones that are of the same kind. So where you get to see that is when there are repetition. like for example, you want to arrange the letters of the word egg. This GG, you cannot distinguish them. So they are the same. So in this case, you want to arrange this now. Your N is 3, but you have GG, which they are of the same kind, and there are 2 of them. Do you understand that now? So it means there are 2 indistinguishable items or objects. And what is the indistinguishable? It is 2G. Do you understand? So that is it. So that's where you get to use that. For example, now I have like roughly 5 more minutes to spend. So I would explain combination in another class to try to understand what permutation is all about. And I would pause here for the combination class. So where are we? Okay, so let's say now we want to arrange examples now. Examples. In how many ways? In how many ways can the letters in the following words be arranged? So the first one, let's say the first one is daily. So for daily, you have n. The number of items there is 4, right? 1, 2, 3, 4. The indistinguishable items is the number of is you have there. They are just 2, and that's all. So it means the number of ways of arranging daily is just going to be 4 factorial divided by, because you have 2 is, that will be 2 factorial, and 4 factorial is 24. 2 factorial is 2. The answer is 12. Can you see that's daily? B now. B. Let's say we want to arrange the letters of the word Solomon. Solomon. Here, how many items do you have? 1, 2, 3, 4, 5, 6, 7. You have 7 items. So n is 7. But the number of O's that you have there, they are 3. So in this case, the number of ways of arranging Solomon is going to be 7 factorial divided by 3 factorial. If there are more than 1 items that are indistinguishable, if there are more than 1 item that are indistinguished, you bring them down. You still multiply by this 3 factorial, you multiply by another, the number of another item that is also indistinguishable. So this one is going to be 7 times 6 times 5 times 4 times 3 factorial over 3 factorial. Do you get now? And when you do that, it's going to be, this 3 factorial can cancel out. Do you get? So now you have 42 times 20, which is 840. So number of ways in that case is 840. That's example 2. See now. Abakaliki. Abakaliki. In how many ways can the letters of the word Abakaliki be arranged? Now the total number of letters that we have there, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Okay. You have A's. A's are repeated. How many A's do you have? 1, 2, 3. 3 A's. How many K do you have? You have K's. You have how many K's? 2 K's. Right? You also have 2 I's. 2 I's. Any other letter that was repeated? None. That's all. So if you want to know the number of ways of arranging Abakaliki now, the number of ways of arranging Abakaliki will be 9 factorial over 3 factorial times 2 factorial times 2 factorial. I'll leave you to decide the final answer to this. And you can send your final answer after doing your rough calculation. Send it to the comment box, and I'll tell you if you're right or wrong. This is where I'm going to stop your permutation class, and I hope that you do understand the whole question and the whole concept. So, and this is the extent why JAMB and NECO can ask you on permutation now, please. We are still on permutation. We have not done combination. So our next class, the next video is going to address combination from the beginning up until the end. Once again, don't forget to share this with your friends, share it with your classmates, share it with students of mathematics in JAMB, students of mathematics, maths in NECO, in WAEC. Okay, this is going to go a very long way, right? So that is it. I hope that the understanding is very clear. I do hope that so now go to your past questions and solve as many questions as you can. on permutation. I've not taught you combination. So this is permutation and factorial. This is everything you need to understand. Any question that will give you a problem, come to this comment section and drop it there. We're going to solve, we're going to provide solutions to it. I wish you guys the best. Take good care of yourself. And bye. For now, I'm Ridwan Abdulhab. I'm the popular Haji Too Much, the founder and director of Too Much Academy. If you have any academic challenge, any academic issues, any challenge whatsoever, feel free to reach out to me anytime, any day. I'm here to support you. I'm here to assist you. Take good care of yourself once again. Don't forget to like, share, and spread this beneficial video to everyone around you. Bye for now.
Too Much Academy.